Is the board visible, all of you? Is it visible, all of you?
Yes.
Right. So let us quickly begin. So what they have given in this situation is work done in moving a unit positive charge from point P to A, it seems, is WA. From P to B is WB. So are we moving under the influence of one of the charge or not? We are moving it under the influence of one of the charge, guys. So initially it is at P. From P it is moved to A. Then again it is moved from P to B. The work done in moving a unit positive charge from point P to A is WA, and from P to B is WB. So let us imagine, what are they asking? They're asking us which work will be more. So let us imagine from Q, this is at a distance x. Right. So what is the work done basically? When work is done by external agent, we can write work done by external agent as change in potential energy, guys. What we can write? Change in potential energy. So initially, let us say it is at a distance x. So what would be initial potential energy in either of the case, whether it is taken from P to A or P to B? It is under the influence of Q again. So what will be the initial potential energy, guys? You can consider initial potential energy in both the cases will be K capital Q small q divided by x. Yes or no? Now what will be final potential energy in case of A? Now, when I take a positive charge from here to here, final potential energy will become how much better? K capital Q small q divided by R. In the same manner, final potential energy while taking from P to B will again be how much better? K capital Q small q divided by R. Now you see, you do the change in potential energy in both the cases, whether you take from P to A, right? P to A or from P to B. What will I get? You are going to get the same value again. Clear, all of you? The work done at A minus work done at B will be equal to 0 also, you can write. And you can say this also, because work done in moving from P to A minus work done moving from P to B will be 0. That is correct. And work done at A should be equal to work done at B. So both 1 and 3 will be correct. Clear, all of you? Yes or no, everyone? In both the cases, whether you take delta U in first case, you will get K capital Q small q into R minus K capital Q small q divided by X. And in second case also, if you do, you will get it as K capital Q small q divided by R minus K capital Q small q divided by X. So in both the cases, change in potential energy will be same. So work done in both the cases will be same. So WA will be equal to WB. Clear, all of you? Whenever two charges are separated by distance r, on yesterday I have discussed, guys, whenever two charges are kept at a separation r, the expression for potential energy will be K q1 q2 divided by R. Yes or no? Right. Similar type of question you got in 2022, guys. Two conducting spheres of radius r1 and r2 have same electric field near the surfaces. Right. If you take a sphere again, right, inside the sphere, because it is conductor, inside the conductor, what would be field, guys? What would be field inside the conductor? It is going to be 0, as you all know. Yes or no? Right. Just outside, if I consider, what would be the electric field? Let us say for first sphere, they have same electric field, it seems, and they're asking what is the ratio of potential, electric potential at their surface. So just near the surface, I can consider it will have a field of kq1 divided by r1 square, and electric field E2 will be kq2 divided by r2 square. Yes or no? What will be potential on the surface? You will write it as kq1 divided by r1. V2 value will be kq2 divided by r2. Both of them have same electric fields, they are saying, guys. So as E1 value is equal to E2, what we can write from this? We can write kq1 by r1 square should be equal to kq2 by r2 square. So what I will write from here is, I will write kq1 by r1 into 1 by r1. Are we making any change? No. In the same manner, I will write kq2 by r2 into 1 by r2. Are you making any change, guys? No. So what is this kq1 by r1? It is potential on the first sphere. kq2 by r2, it is potential on the second sphere, guys, on the surface of the second sphere. So what we can write, v1 by r1 will be equal to v2 divided by R2 implies I'll get the ratio of their potentials in the ratio of radii. Clear, everyone? Yes or no, all of you? Did you understand? Electric field inside the conductor will be how much? Electric field inside the conductor will be 0. So electric field will be just outside the conductor. How much electric field again? Same as that on the surface. KQ1 by R1 square, KQ2 by R2 square. Both these electric fields are equal, they have said. So from this we can say the ratio will be R1 by R2. Understood, all of you?
Yes,
Yes
sir.
or no? Electric dipole is placed in an electric field due to a point source. What is electric field due to a point source, guys? Yesterday again we have seen. Again, if I take a point charge and I am interested in finding electric field at point P. At what distance it is? It is at a distance, let us consider some r from the given charge. So at any point, if you want to find field, force, potential energy, at that point, what are we going to place a test
Yes,
charge?
sir.
So what will capital Q charge do to small charge, beta? Is it going to repel or not? So this is the force acting. How much force is going to act? K capital Q small q divided by r square. So what is force acting? Electric dipole is placed in electric field produced. Force per charge, is it electric field or not, guys? It is given as kq divided by r square. This is the electric field produced due to a point charge. Now whether it is uniform or non-uniform, can you please tell? For a given charge, k will be constant, q will be constant, but will small r be constant, guys?
No.
Distance from the charge can be changing. So what is this field? Electric field produced by a point charge is a non-uniform field, guys. And I have told you yesterday, whenever a dipole is placed in a non-uniform field, will it always experience force, beta? Yes. While it may or may not experience torque. So out of the given options, which will be correct? Force experienced by dipole will always be non-zero, while torque may or may not be zero. Second one will be correct. Second statement is correct or not, everyone? Uniform field, force always zero, torque may or may not be zero. Non-uniform field, force never zero, torque may or may not be zero. Yes or no, everyone?
Yes, sir.
Right. See next question. Two particles of mass m and 2m with charges minus 2q and 2q are placed in a uniform electric field and allowed to move for same time. The ratio of their kinetic energy, it seems. Okay. Same again. We have two particles, guys. This is one of the particle. In the same manner, we have this one as another particle. One of them has mass m. Charge is how much, beta? Minus 2q. Other has mass 2m. Charge is how much? 2q. Let us imagine electric field is along positive x direction. Uniform field, guys. One very important thing that you need to know, right? Whenever we talk about a charge placed in electric field, whenever a negative charge is placed in electric field, what is going to happen? It is going to experience a force opposite to the direction of field, guys. So it will experience some electric force. In the same manner, whenever a positive charge is placed in electric field, it will experience a force in the direction of field, guys. So initially you can consider both of them are at rest. Now what is going to happen? Is this an unbalanced force or not, guys? Yes, this is an unbalanced force. Also, this is an unbalanced force. So because these are unbalanced forces, what will happen to the negative charge? The negative charge is going to get accelerated along negative x direction. Positive charge will get accelerated along positive x direction. Right. So in both the cases, is it an unbalanced force or not? Yes, it is an unbalanced force. So what is the net force in both the cases? Fe you can write, which will be given as magnitude of charge times of electric field. Here also, what is the net force, beta? You are going to get it as Fe, which will be equal to again 2q into E, right? So net force can be written as mass times of acceleration. So m into A1, I can write it as 2qE. So A1 value, I'll get it as 2qE divided by m. Yes or no? In the same manner, I can write here, what is the mass here? 2m, beta. 2m A2 will be equal to 2qE. So what will A2 value be, beta? You will get it as qE divided by m. Now they are saying they are allowed to move for same time. then what is the ratio of kinetic energy they are asking, guys? Now, initially, in both the cases, what are the velocities? You take this case, velocity 0, this case also velocity 0. Is it a uniform acceleration or not? 2qem. QEM. These two accelerations are constant accelerations, guys. Now, because they are constant accelerations, and let us say they are being accelerated for some t time, guys. So, can I apply for both the cases? Can I apply v bar is equal to u bar plus a bar into t? So, initial velocity anyhow will be 0. So, let us say they are attaining some speed v1 and v2. So, what will v1 value be? It will be a1 into t. What will v2 value be, beta? It will be a2 into t. Right, so I can write v1 value as 2qe by m into t. In the same manner, I can write v2 value as qe by m into t. They're asking us to find ratio of kinetic energy, guys. So how will you find the ratio of kinetic energy again? Directly k1 by k2. Is it half mv square or not? So I can write m1 divided by m2 into v1 square divided by v2 square. Now if you look at this, how much is v1, guys? If you just compare both of these, will I get v1 value as 2 times of v2 and m2 value, how much is m2 value? Is it 2 times of m1 or not? So what will I get m1 by m2 as? M1 by m2 I'll get 1 by 2. v1 by v2 you will get 2, guys. So if I take 2 square, the answer should be 2 is to 1, guys. Clear all of you? What is the concept involved in this? Whenever a positive charge is placed in an external field, it will experience a force in the direction of field. Whenever a negative charge is placed in an external field, it will experience a force opposite to the direction of field. And in both the cases, these are unbalanced forces. They are going to give us the net force. So acceleration we have found out in both the charges minus 2q and 2q are being accelerated for same time. Let us say the time is t. So their ratio of kinetic energy they have asked. So we got it as 2 is to 1. I hope you have understood, all of you. Yes or no? I hope it is clear. Next question, let us
Yes.
see, guys. The flux the flux entering and leaving a closed surface are 3 into 10 power 5 and 4 into 10 power 5 mks unit respectively. The total charge enclosed inside the closed surface will be how much they are asking. What will it be, guys? Total charge enclosed. However, the surface may be. Usually, when I talk about surface, guys, the uh, whatever flux is entering, that usually will be negative, and flux which is exiting usually will be positive. Flux leaving will be positive, flux entering will be negative, guys. इसको क्या हो गया? Is it visible, all of you? Is the board visible?
Yes.
Right. So when we talk about the total flux, so it will be flux entering and flux leaving. Why? Because, right, whenever we take let us imagine a sphere, guys. Okay, if I imagine a sphere, something in this manner, and we have electric field lines in this manner, guys, along positive x direction. So while it is entering, it will appear for us as if it is entering in this circular area. While it is entering, it will appear as if it is coming from this particular area. It is entering into this area, guys. And while it is leaving, it will appear as if it is going to leave from this area. Are you getting my point, all of you? So if you take a sphere, while the electric field lines are entering, I am imagining that electric field lines are along positive x direction. Uniform field, let us take, guys. Okay. So what will be the situation now? Electric field is inwards, but how will area vector be? As I've already told you, area vector will always be perpendicularly outward. Here area vector is like this. So in both the cases, you see electric field is along positive x direction. But in first case, the flux entering, area vector is along negative x direction. So flux entering will be negative, flux leaving will be positive, guys. So if you talk about the total flux associated, what will be the total flux now? Can you please tell? Entering flux will be negative or not? Minus 3 into 10 power 5. Yes or no? Plus 4 into 10 power 5. Okay. So what will be the total flux associated now? I'll get it as 1 into 10 power 5 MKS unit, E bar dot A bar you will write, guys. So Newton meter square per Coulomb you will get. Clear all of you? This is the total flux. And as per Gauss law, what is the total flux associated with the closed surface? The total flux associated with the closed surface. How much will be the total flux associated with the closed surface? Q enclosed divided by epsilon naught. So what is Q enclosed, beta? It will be the total flux into epsilon naught. So I'll get it as 10 power 5. Epsilon naught, it is 8.85 into 10 power minus 12. So I'll get it as how much, beta? 8.85 into 10 power minus 7 coulomb. Clear all of you? So remember, flux entering will usually be negative, flux exiting or leaving will usually be positive. So 8.85 into 10 power minus 7 coulomb would be the correct answer. Clear all of you? Yes or no? I hope you understood. I have just explained you with the help of a sphere, guys. When a sphere is placed in an external field, these field lines will appear to enter as if they are entering in a circular area. And these field lines will appear to leave from again this circular area. So while it is entering, electric field vector and area vector will be in opposite direction. While they are leaving, electric field vector and area vector will be in same direction. So this flux will be positive, this flux will be negative. Total flux, as you all know, it will be flux entering plus flux leaving. So you'll get it as 1 into 10 power 5. And from Gauss law, flux can be written as Q enclosed divided by epsilon naught. Understood all of you? I hope it is clear. Next case you see, two concentric spherical conducting shells of radius r and 2r carry charges q and 2q respectively. So for a conductor, where will the charge be, guys? Yesterday, one of them has asked the question. We did one question again. For conductors, where will the charge be?
On the surface.
Right, it is going to get distributed on the surface. They're asking change in electric potential of inner shell when they are connected by a conducting wire. So initially both of them are separate, guys. It is a concept of sharing of charge only. So we will just try to understand two concentric spherical conducting shells of radius r and 2r. So let me just take two shells, guys, here.
So,
Mm.
so whenever the flux is going outside, I mean, when it's going out inside, do I have to take it as negative or
जब से
usually?
क्या बोल रहे हो भाई मैं?
So, is it just that I mean, even while just taking it, the
In
flux
every
will follow?
case I told no, just no.
Okay, sir.
Just now I have told no. Right. So on the inner charge, you have plus q charge, guys. On the inner shell. On the outer shell, you have plus 2q charge, I guess. Inner shell has a radius r. This has a radius 2r. Okay. Now they have. Let us just come back to the question once again. They are saying that two concentric spherical conducting shells of radius r and 2r carry charges q and 2q respectively. Change in electric potential of inner shell when they are connected by a conducting wire will be how much? So initially, you please tell me if they are not connected, guys. Initially, what would be potential? V1 initial I am writing. I'll take on the surface. Inside and surface, they will be same, guys, because electric field inside is 0. Electric field inside 0 means potential will remain constant always. So if I take this particular point, what will be potential here? Will be kq divided by r, right? And always remember, potential whenever we are writing, guys, potential will always be, again, we will follow principle of superposition in that. So what would be potential at this point q? So we got kq by r. This is due to the inner shell. Now due to outer shell, what will it be, guys? Due to outer shell, what will it be? It will be k into 2q divided by 2r. Okay, so at this point, initially, what is the potential, beta? Initially, what is the potential? It will be due to the inner shell. It will also be due to the outer shell. This point is lying on the inner shell. So because this point is lying on the inner shell, potential will be kq by r. And this point is lying inside the outer shell. Inside the shell, potential will always remain constant, which is kq divided by radius, guys. So here k into The charge of the outer shell is 2q divided by 2r. So kq by r and kq by r you will get, this will be 2kq divided by r. Okay. What is the initial potential of second point you take somewhere over here? This is first point, second point. Second point, is it lying outside the inner shell? So due to inner shell, I will get kq divided by distance is 2r. And because it is lying on the outer shell itself, I will write k into 2q divided by 2r. Clear all of you? So kq by 2r and kq by r, you will get it as 3kq divided by 2r. Now see, which has more potential, guys? Inner shell or outer shell? Which has more potential, inner shell or outer shell? Array, which has more potential? See, 2kq by r for inner shell. For outer shell, 3 by 2 kq by r. So inner shell has more potential or not? Yes. So whenever you connect them with the help of a conducting wire, what is going to happen, beta? There will be charge flowing from where to where? From inner shell to outer shell. How much charge is flowing? Let us say small q charge is flowing, guys. Okay, now what will be the final potential? Sharing of charge will take place until both of them attain same potential or not? Yes. So what we can write here? Finally, if I consider V1 final. So if Q charge has flown, what will be charge on this? So I can write K capital Q minus small q divided by R plus K into 2q by small q divided by 2R. Similarly, what will be potential on second surface, guys? Same thing again. K into q minus q divided by 2r plus k into how much? 2q plus q divided by 2r. Now, sharing of potential take place until both of them attain common potential. Yes or no? So what we can write here? K into capital Q minus small q divided by r plus k into 2q plus small q divided by 2r should be equal to k into capital Q minus small q divided by 2r plus k into 2 capital Q plus small q divided by 2r, guys. Yes or no? Are we getting any mistake or did I do any mistake? Just check once. Hmm. So again, basic thing you can say, when will their potentials be same, guys? If the entire charge is getting transferred. Okay. What I can say is if this entire charge is getting transferred, no, you can directly say the potential will be different again. So what we can write here from this, can we cancel out this k 2q plus q by 2r, k 2q plus 2 by qr, we can cancel out. From this, what will be left? What I'll get is q minus small q will be equal to q minus small q divided by 2 you will get, guys. So what we can write, 2q minus 2q will be equal to q minus q. So small q value will be q. So entire charge if it is transferred, then only, again it is basic logic, guys. Huh? I missed that logic, but still. So when will potential be same? If whatever is the charge on the inner surface or the inner shell, if it is getting completely transferred to the outer shell, then potential will remain same. So what will be the potential now? They are asking us to find change in potential, no? When they are connected by a conducting wire, change in electric potential of inner shell they are saying, right? What would be initial potential? 2kq by r we got. And finally, see, the entire charge got, entire charge which is present on the first shell now got to second shell, guys. So what is the new charge here? On the outer shell, 3q. On the inner shell, how much? 0. So now I will find the new potential, beta. So what is new potential on first, on 1? V1 final if I consider. Due to inner shell, it will be 0. But due to outer shell, what will it be? K3q divided by 2r. This much it will be. So initially you have 2kq by r. Now it became 3kq by 2r. So what is change in potential in 1? It will be V1 final minus V1 initial, which I can write it as 3kq divided by 2r minus 2kq divided by r, which I'll get it as minus kq divided by 2r, guys. Okay, so minus 1 by 8 pi epsilon naught q by r you will get. Let us see if it is there. It's good. So which will be the answer, guys? Second option will be the answer. Clear all of you? Is that clear, everyone?
Yes, sir.
Right. So there is no necessity of doing all this, guys. First, you can find initial potential. Okay, initial and final potential. Initial potential of the inner shell. So anyhow, you have to find. Okay. How we have found out? It's a very basic concept again. What we have used, guys, we have made use of the concept of potential at a point will be the algebraic sum of potential due to all the charges present in the system. So potential at first point will not only be due to charge on the inner shell, it will also be due to charge on the outer shell. Now, whenever you connect them with the help of a conducting wire, in order for again, obviously, when they are connected with the help of a wire, charge transfer will take place. We know yesterday we have seen sharing of charge will take place until both of them attain common potential. So for both of them to attain common potential, what is the basic logic is whatever charge is there on the inner shell, that entirely will get transferred to the outer shell. So once it got transferred, then I found out the final potential on first shell. So we know initial potential on first shell, final potential on first shell. So subtract both of them, you will get the change in potential. Okay, so potential here is decreasing by minus sign indicates it is decreasing by kq divided by 2r. Clear? Understood, all of you? Guys, is it clear?
Yes, sir.
I just proved here that in order for both the inner shell and outer shell to be at same potential, what all charge is there on the inner shell will get transferred to the outer shell. I have proved it here, guys. But anyhow, you can remember it as a general point again. Now, what they are asking is velocity acquired by a proton starting from rest and moving through a potential difference v as shown by the figure. So we have to plot velocity versus potential difference variation for proton, guys. Now, it is starting from rest, it seems. When it is accelerated through v volts, what will be the kinetic energy, beta? I'll just show it. I'll write it here. So the kinetic energy through which it got accelerated will be charge times of potential difference. What it is? Q into V. Now, what is kinetic energy? Change in kinetic energy you can consider or work done.
Half MB square.
So let us just go back once again to the question. So they have asked us to plot what is the relation between velocity acquired by a proton starting from rest and moving through a potential difference V. So whenever there is potential difference, it means there is some work done, guys. So what is the work done? This change in potential energy we can write. So work done can be written as charge times of potential difference. And we know from work energy theorem, work done by all forces will be change in kinetic energy. So change in kinetic energy will be Q into V. Initially, kinetic energy is not there. So final kinetic energy, I can write it as half mv square will be equal to Q into V. Now, as you can see, V square will be directly proportional to V, guys. So where is V written on y-axis? So is y square directly proportional to x or not? Yes or no? So whenever y square is directly proportional to x, you will get a parabola again. How will that parabola be, guys? Y square is equal to proportional to x will be something like this. This parabola you will get. Third one. Please remember y square proportional to x is in this manner. Okay. And y square proportional to minus x will be like this. Similarly, x square proportional to y will be like this. And x square proportional to minus y will be like this. Clear, all of you? Very important graphs again. These are all parabolas only. This will be y square proportional to x. This will be y square proportional to minus x. This will be x square proportional to y. And this will be x square proportional to minus y. Clear, all of you? So we got y square proportional to x, guys. So third option will be the answer for it. Clear, all of you? Understood, everyone? Whenever it is accelerated through some potential difference, some work will be done. That work done will be written as charge times of potential difference, and work done can be written as change in kinetic energy, guys. Clear? Yes or no? What they have given, you see. Next question, if you see electric field in a region is given by, the electric field is given as 3i cap plus 4y j cap, guys. Okay, they are asking us to find out what would be potential at a point whose coordinates are 2, 1. Now, can I write this as electric field is given as Ex I cap plus Ey j cap. Can I write all of you? Yes or no? So if I compare both of them, what will I get Ex value as? I'll get it as 3 Newton per Coulomb. And I'll get Ey value as 4y Newton per Coulomb. Yes or no, all of you? Volt per meter or Newton per Coulomb you can write. And whenever electric field is varying with both Ex and Ey, what will be potential difference, beta? Right? You will get it as integral of Ex dx plus integral of Ey dy. And I'm going to keep it in minus sign, guys, because you know d is written as minus of electric field is minus of dE by dr, no? So I'll write it something like this. So V value will be minus of integral E of x dx plus integral E of y dy. So it is moved from where to where? From origin, or to be precise, guys, we'll write dV again. So from where to where we are moving it? From origin. So here x value is 0 and to a point P where x coordinate is 1. Here again initially y coordinate 0, now 1. So initially here it is potential at origin and V potential at P, guys. So integral dV, as you all know, what will it be? What is integral dV, beta? Integral dV will be V only. From where to where? From V naught to Vp should be equal to minus of integral 3 dx from 0 to 2 plus integral 4y dy from 0 to 1. I hope you understood this. Yesterday we have seen the relation, guys. If you substitute the limits, what are we going to get? Vp minus V naught will be equal to minus of 3 is a constant value, we can bring it outside. What will integral dx be, beta? X from 0 to 2. Plus 4 is a constant value, we can bring it outside. Integral y dy will be y square divided by 2 from 0 to 1. So what is potential at origin taken to be? Potential at origin is considered to be as 0. So what we can write potential at point P as minus of, I'll get it as 3 into 2 minus 0 is 2 only, plus 4 into 1 by 2 minus 0 will be 1 by 2 only. So 6 plus 2 will be minus 8 volts, guys. It's a very important question. Good question again. Clear, all of you? Whenever electric field is varying with all x, y, and z, the potential will be written as minus of integral E of x dx plus integral E of y dy plus integral E of z dz. Understood? What will be the potential at point P, beta? You're going to get it as minus 8 volt. Clear? Hey, అర్థమైందారా రే?
It's
Right. Let us see next case. N identical drops of mercury are charged simultaneously to 10 volts. When combined to form a large drop, the potential is found to become 40 volts. The value of N they are asking, guys. Right? We have seen yesterday when N drops are combining to form a large drop, radius will become N power 1 by 3 times. Yes or no? We have also seen charge will become N times. What will potential difference become, guys? Will it become N power 2 by 3 times of initial potential difference or not? Yes or no, all of you? So what is V value, they said? When combined to form one large drop, the potential is found to be 40. This is 40 will be equal to N power 2 by 3. What is initial potential, beta? For each drop, it is given as 10. So what will I get? N power 2 by 3 value will be 4. So if I want to find N value, what I will do? 4 power 3 by 2 I will write or not? What I will get? I can write it as uh, 2 square whole power 3 by 2. Yes or no? So how much will I get, beta? 8 drops you are going to get. Clear, everyone? You have done the question or not? You have seen this yesterday, no? Whenever N drops are combining to form a large drop, capacitance will become N power 1 by 3 times. Charge will become N times. Potential difference will become N power 2 by 3 times. Energy will become N power 5 by 3 times. You have seen this or not, guys, yesterday? So what will be the number of drops that are combining to form large drop? 8 number of drops are combining to form the large drop. Is that clear? I hope it
Yes.
is clear, right? Then now please try to understand, in a region of space, there is electric field, it seems, guys. 8 I cap, 4 J cap, 3 K cap. Electric flux through a surface of area 50 units in XZ plane. Area is present in XZ plane. Area, where is it present? In XZ plane. So what will the direction of area vector be? Area vector, will it always be perpendicular to the plane or not, guys? Yes or no? So here, what is our electric field vector. Electric field vector, we got it as 8 I cap plus 4 j cap plus 3 k cap. But what is area vector? The surface is lying in xz plane. Area vector will always be perpendicular to the plane in which the object is present or not, guys. So what will I get? I will get it as 50 j cap. So they are asking us to find the electric flux, guys. It is a constant electric field only. The electric flux will be given as dot product of electric field vector and area vector. So you know I dot j 0. Only j dot j will be 1. K dot j is also 0, guys. So you are going to get this as 4 into 50, which will be 200 units, guys. Clear, everyone? Understood, all of you? If
Yes.
the area is lying in certain plane, if it is lying in xy plane, its area vector will be along z axis, guys. If it is lying in yz plane, its area vector will be along x axis. Clear? अरे
Yes,
ఎవరు
sir.
కుడుంగ్ కుడుంగ్ అంటారు हाँ हबीबा क्या है
Sorry, sir.
understood.
But
Let us do the next question, guys. An electric dipole consists of two opposite charges, each of magnitude 1 microcoulomb, separated by a distance of 2 centimeters. So A value is given, charge value is given, maximum torque acting on the dipole in a uniform electric field. What is the maximum torque acting on the dipole, beta? If I take only the magnitude, how much is the maximum torque acting? Torque is given as P sine theta or not? The maximum torque will be P into E, which I can write it as charge times of separation into electric field. How much is the charge? 1 microcoulomb. So 1 into 10 power minus 6. What is separation? 2 centimeter. 2 into 10 power minus 2. What is electric field, beta? 2 into 10 power 5. What I will get? Minus 8. 4 into 10 power minus 3 should be the answer. Direct question again. Newton meter. So maximum torque experienced by the dipole placed in a uniform electric field will be PE. Generally, torque will be given as P bar cross E bar. The magnitude will be given as PE sine theta. Clear? Yes or no?
yes, sir.
If you look at the next question, guys, what they are saying, two positive point charges of 9 microcoulomb and 6 microcoulomb are 10 centimeters apart. Work done in bringing them to a separation of 4 centimeters. So initially, if you take two charges, you have Q1 and Q2, let us say. Q1 and Q2, initially they are separated by 10 centimeters. Now I have brought them to a separation of 4 centimeters. What is the work done they are saying, guys? So what is initial potential energy? K Q1 Q2 divided by 10 centimeters you will get. So I can write it as 10 into 10 power minus 2. And what is final potential energy, beta? Again same. K Q1 Q2, but now the separation became 4. 4 into 10 power minus 2. So I can write this as 100 K Q1 Q2 divided by 10. You can write anyhow, you can take it as it is. So you will get it as 100 by 10 will be 10 only, no? Yaar. Here 100 by 4 you will get it as 25 K Q1 Q2. So what is the work done with that? It will be change in potential energy, which is final minus initial. Finally, you have 25, initial you have 10. So overall you will get 15 K Q1 Q2, right? 15 into K value, as you all know, it is 9 into 10 power 9. Q1 is 9 microcoulomb. I'll write directly later, guys. Q2 is 6 microcoulomb. 9, 6, 54 and 10 power minus 12 you can take. Clear, all of you? So what are we going to get? 15 and 54 you will get, guys. 81 you will get again over here. Or you can take 15, 6, how much? 120 or not? Yes or no, yaar? Sorry, 15, 8 is 120. So 15, so you'll get 90 into 9 into 9, which is 81 you can write. Okay, 81 into 10 power minus 3 you will get, guys. Which I can write it as 9 into 0.81. Near about 7 point something. 7.29 will be the answer. Clear, everyone? Direct question again. Whenever two charges are kept at some separation r, what is the expression for potential energy between them? K Q1 Q2 by R. So initially they are kept at some 10 centimeters. Now they are kept at some 4 centimeters. What is the work done they are asking, guys? So work done will be change in potential energy, which is U final minus U initial. Understood all of you? Yes or no? Let us see next question. A thin conducting spherical shell of radius r has a charge 2q. Another charge q is placed at the center of the shell. The electric potential at a point P at a distance r by 2 from the shell they are asking. Right? It is also a good question, but it is a direct question, guys. So you have taken a shell. A thin spherical shell has a charge 2q. So how much is the charge of this shell, beta? 2q. Apart from this, we are placing another charge at the center. How much charge are we placing at the center? Q charge we are placing. They are asking us to find what will be the electric potential at a point P, which is at how much distance? It is at a distance r by 2. Clear all of you? It is at a distance r by 2. They are asking us to find what would be the potential, guys. So thin conducting spherical shell. So inside a conductor, what is the condition, guys? Potential everywhere will remain constant, electric field will be 0. Now please tell me, potential at any point if you want to find, it will be algebraic sum of potential due to all the charges present in the system. Okay, this is a very important case, guys. A point P, is it lying inside the shell or not? So whenever a point is inside the shell, potential will always remain constant. So what I can write? K into 2q divided by r. This will be the potential due to the outer shell. And due to the point charge, at how much distance is the point P from the charge, guys? So I can write kq divided by r. So r by 2 you can write. So you'll get it as 2kq divided by r plus 2kq divided by r. So overall you'll get it as 4kq divided by r. So what should our answer be, beta? First option should be our answer. Clear all of you? Always remember this point. Potential, whenever you are finding at a point, it will be algebraic sum of potentials due to all the charges present in the system. Is it clear, all of you? Understood, everyone? Am I audible? Am I
Yes, sir.
audible? Next question, let us see, guys. Two equal positive point charges are held at fixed distance apart. A point test charge is located in the plane that is normal to the line joining these charges and midway between them. Radius of the circle in this plane for which the force on the test particle is maximum, they are asking. Two equal positive charges are held at a distance, fixed distance apart. A point test charge is located in a plane that is normal to the line joining these charges and midway between them. Okay. Radius of the circle in this plane for which the force on the test particle is maximum. Where is the force maximum, they are asking, guys. Okay, so if I just look at this question, so maybe you can take it something like this. So you have two equal positive charges. Separation between them is given as A. So you have two charges here. One is charge, again, both are small q charges only. A point test charge is located. See, instead of taking small q, guys, because test charge I'll take capital Q. So I'm just taking this as capital Q. So where is a test charge located? They are saying a point test charge located in a plane that is normal to the line joining these charges, it seems. It is lying in a plane normal to the line joining these charges. So if, okay, and midway between them. So what will be the plane which is normal to this particular axis, x-axis? Will it be YZ plane or not? So it will be YZ plane. So it means it is placed in YZ plane, something like this, guys. So if I take a plane surface here, it will be placed in YZ plane. And where is it exactly now? It is in midway between them. So they're asking what would be the radius of the circle in this plane for which the force on the test particle is maximum. I hope you have got the question, all of you. Dekho, how is the line? X-axis. Which plane is perpendicular to x-axis? YZ plane. Yes or no? And where is that plane lying? That plane is lying exactly at the center, guys. That plane is lying midway between them. This is the center again. So what would be this distance from here to here? You will get it as a by 2. From here also you will get it as a by 2. Now where is the test charge lying? The test charge is lying somewhere in this particular circle, in this plane, and that too in a circle they are saying. So radius of the circle in this plane for which force on the test particle is maximum. So the test charge is lying somewhere in this plane, guys. Okay. So just to take this question, so what I'll assume is, let us say when that particular test charge is somewhere over here, which is at a distance x from the midpoint. Let us imagine that force is maximum. Okay. So this is the condition, guys. Again, it is one of the previous year question only. This is the condition now. So I'm just taking it separately now. I hope you understood the question, all of you. Two fixed charges are there. You have a plane which is perpendicular to the line joining the charges. So the line is x-axis. Plane perpendicular to x-axis will be YZ plane, which is vertical plane. And in this plane, a test charge is moving in such a way that force on it is maximum. So what is the radius of that test charge? Radius of the circle moved by the test charge they are asking. So what I'll do is, let us take the midpoint somewhere over here, guys. And I'm assuming at this particular position of the test charge, right? And what is the distance, beta? At distance x, force on it is maximum. Okay. So what we can write from here to here, what is it given as? A by 2. In the same manner, from here to here also it is A by 2. So what will happen in this situation, you see? First of all, capital Q and capital Q. Are they both going to exert some force of attraction or not? Yes. And that force will be same. Why? Because this is x, this is a by 2. So it will be under root of a by 2 whole square plus x square. This will also be under root of a by 2 whole square plus x square. So I'll write it as small r beta. Both of them will apply same force again. Let us say that force is F. Now, because they are applying same force, guys, now what we can take, right? Will it be an isosceles triangle or not? See, R and R, two sides are equal, means corresponding angles will also be equal. Yes or no, yaar? Yes. So what we can take is, let us imagine this is our horizontal. This is our vertical. So what we can take, these two angles will be same, guys. If this is theta, then automatically you can say this angle will also be theta. So if this is theta, I can write this value to be theta, and automatically this will also become theta. If you see, if I resolve the components, here we got f cos theta. Here also I'm going to get f cos theta. Both of them will cancel out each other, leaving out only which component, beta? Vertical component. And how much will that vertical component be? Here I want to find the value of x. Okay, please keep that in mind. So from left hand side, one component f sine theta. From right hand side also one component f sine theta. So I'll get it as 2f sine theta, beta. Again, integration is required, differentiation is required in that. So net force acting on the test charge should be 2f sine theta. What is f value now? 2 capital K small capital Q small q divided by small r square. And how will I write sine theta value as? Can I write it as x divided by r or not? Yes, I will write it as x divided by r. So what are we going to get here? If you can just write the net force, you will get it as 2k capital Q small q into x divided by r cube. And what is the small r value, beta? 2k capital Q small q into x divided by small r value, will it be under root of r square plus x square or not? Yes, it will be under root of r square plus x square. You will get it as r square plus x square. Under root is there, so I can write it as 3 by 2. Now if you see, will 2 value change? No. Will k value change? No. Will capital Q value change? No. Will small q value change? No. Will capital R is nothing but a by 2 here, sorry. So will I get a by 2 whole square or not, guys? Will a by 2 value change? No. What is changing here? X will be changing, guys. So what we can do here, for maximum force, because variable is x, guys, for maximum force I can substitute df net divided by dx will be equal to 0. First derivative should be equal to 0, guys. Clear, all of you? Right. Now so you can, if you just solve for that, no, what will you get? Please remember like this, guys. If you take a ring, you will have maximum forces r by root 2. So here imagine if it is a ring of radius a by 2, you will get a by 2 root 2. So a by 2 root 2 should be the answer for it. Okay, if you solve for it, you will get. If you differentiate it, you will get it, guys. If you want me to perform differentiation, I'll do it. That's not a big deal. I hope you understood the question. Two charges are fixed. There is a plane which is perpendicular to the line joining the charges. If I assume line joining the charges to be x-axis, how will the plane be? It will be in yz plane. A test charge is moving in yz plane. So they are asking what should be the radius of the circle such that force experienced by the test charge is maximum. So I have imagined that it is experiencing maximum force at a distance x beta. So what we will get, 2f sin theta will be the net force, and that force will vary with x. So in order to find the maximum force, we can write df by dx should be equal to 0. If you solve for this, you will get the answer. Clear, everyone? So I think you will get it as x value will be a by 2 whole divided by root 2, which is a by 2 root 2. Okay. I hope it is clear, all of you. Am I audible?
So could you orally tell that how do we find minimum and maximum? Orally.
If first derivative should be equal to 0. Orally अगर मैं कहूँ तो वही होगा. First derivative should be equal to 0.
So
So
after
here
that
what
also
is
we
the
do
variable?
same.
Not necessary to do. First derivative equal to 0, you will get the value of the variable. That variable you will get. At that variable you will have maximum or minima. You will take that value and substitute in the given equation. Suppose if they are asking to find maximum force, so I'll find the value of x, which I'll obtain by doing first derivative and equating it to 0, and I'll substitute in the force equation in order to get maximum force.
How do we know that it is minimum or maximum? I mean,
वो सेकेंड डेरिवेटिव करेंगे, उसकी जरूरत नहीं है अभी तो.
okay, sir.
Two concentric conducting thin shells of radius r and 2r carry charge q and 3q respectively. The magnitude of electric field at points A and B at a distance x outside and inside from the inner surface of the outer sphere is same, it seems. क्या बात है? So what they have given here? Two concentric conducting shells. Conductors are given. Conductor means automatically, will there be any field inside, beta? No, you are not going to have any field inside. You can imagine it is something like this. So two conducting thin shells of radius r and 2r carry charge. So inner shell is carrying a charge q, outer shell is carrying a charge 3q. They are asking the magnitude of electric field at points A and B at a distance x outside and inside from the surface of the outer sphere. So if this is outer sphere, we have 2 points. One is a point somewhere over here, A, which is outside, and there is another point B inside, guys. So you can take from the surface, B is inside. Okay, you can take somewhere over here. Both are at same distance or not? Both are at how much distance? They have mentioned that both are at a distance x from the surface of the outer sphere. What is the value of x if field at A and field at B are same? Yeah. Clear, all of you? What they are saying, if field at A is equal to field at B, what is the value of x? Now, very simple logic. Where is B present? B is present outside the inner shell. So due to inner shell, there will be electric field. But because it is present inside the outer shell, due to outer shell, electric field at point B will be 0. So what is it due to inner shell, guys? It is kq divided by Radiuses are given. Are radiuses mentioned, guys? Two concentric conducting thin shells of radius r and 2r. Okay, radius are given. So from here to here, what is the distance you see? From center to here, it is 2r. And from center to here, it is r. Please try to understand what will, from here to here, what is the distance going to be now? Will it be 2r minus x or not? Yes, it will be 2r minus x. So what is electric field at B beta? You will get it as kq divided by 2r minus x whole square. Is that clear? Right. And due to outer shell, will there be any field? See, very simple logic. Point B is lying outside the inner shell. So so when a point is outside the shell, you can concentrate the whole charge at its center, guys. So distance between the center and the given point is 2r minus x. So I'll get the field at point B as kq divided by 2r minus x whole square. Whereas at point A, it is external to both inner shell and outer shell, guys. So due to inner shell, what will it be? Kq divided by, from here to here 2r, from here to here x again. So you'll get it as 2r plus x whole square. In the same manner, due to the outer shell, you'll get it as k into 3q divided by, again from here to here, you'll get it as 2r plus x whole square. Is that clear, all of you? Yes or no, beta? So from this, what will I get? 4k capital Q divided by 2r plus x whole square will be equal to k capital Q divided by 2r minus x whole square, beta. What we can cancel out? K capital Q will get cancelled out. So I am going to get 2r plus x whole square divided by 2r minus x whole square should be equal to 4. Implies I can write 2r plus x divided by 2r minus x will be equal to what, beta? 4. So from this, what are we going to obtain now? Will you get the value of x or not? So 2r plus x will be equal to 8r minus 4x. So 5x value will get it as 6r. So x value will get it as 6r divided by 5, which is 1.2r, guys. Clear, everyone?
The root 4, right?
हाँ, रूट था इसको, रूट 4 तो 2 कर दो उसको. You take it as 2 here. So I'm going to get it as 4r minus 2x. With 4r minus 2x. So I'll get it as 3x over here and you'll get 2r over here. 2 by 3r you should get. Clear, all of you? So 3x will be equal to 2r, x will be 2 by 3r. Understood, everyone? Electric field at point A and B are equal, they have given. They're asking us to find the value of x. Did I get 2r by 3? Yes, we got 2r divided by 3. Please remember, guys, just like potential at any point is algebraic sum of potentials due to all the charges present in the system, field at any point will be vector sum here because field is a vector quantity. Field at any point will be vector sum of fields due to all the charges present in the system. Point B is outside first sphere, so there will be field due to inner sphere. But point B is inside outer sphere. Because it is a conductor, field inside will be 0. So due to outer sphere, field at B is 0. But due to inner sphere, field at B will be whatever you want to write, kq divided by 2r minus x whole square. But here A is external to inner sphere as well as outer sphere. So electric field at A will be due to Q as well as 3Q, guys. Clear, all of you? Yes or no? Let us see another question. What they have given here? A spherical conducting shell they have given, guys, of radius 10 centimeters, carrying a charge Q. The electric potential at distance is 5 centimeters, 8 centimeters, 10 centimeters from the center. Radius is 10 centimeters. 5 centimeters, will it lie inside? 8 centimeters also, will it lie inside? 10 centimeters on the surface or not? Yes. So what is the, again they have given conducting, guys, conducting shell. So for a conductor, inside a conductor, electric field will be 0. So where are these points? They are inside only, guys. So electric field is 0 means potential will remain constant. So V1 value, I'll get it as equal to V2, I'll get it as equal to V3. Clear? Is that clear, all of you? Good question again, direct question, all of you.
Sir, outside point will be
Outside कहाँ
on
पे
the
है?
surface.
हर point कहाँ पे है? Every point is inside only, no? Which
10
point is out?
centimeters also.
10 centimeters on the surface, no, it is not outside. And in case of
So,
hollow sphere, in case of hollow sphere, potential inside will be equal to potential on the surface. So whether you take 5 centimeter or 8 centimeter or you take 10 centimeter, potential at all these points will be same. Okay. What was your doubt?
sir, 10 centimeters on surface, no? How it will be equal to the charges which are inside?
Who said charges? They are saying potential, no?
That only, sir. Potential will be inside. So, it will be
Potential
on
in
surface.
for a shell, potential inside and potential at surface both are equal only. Why? Because
Okay.
it is a conductor. Conductor field everywhere inside is zero. Field is zero means potential everywhere will remain constant. So inside everywhere potential will be constant and that will be same as that on the surface. Okay.
Okay, sir.
Next case, if you see, point charge causes an electric flux of 4 into 10 cube to pass through a spherical Gaussian surface of radius 10 centimeters centered on charge. Okay. If the radius of the sphere is reduced to half, then flux that would pass through the sphere. Very direct question, guys. What is flux through closed surface? Flux through the closed surface. What is it given as? From Gauss law. Is it Q enclosed divided by epsilon naught? Initially, radius is 10 centimeters, it seems. And some charge is placed at the center. Now, radius became 5 centimeters. Is same charge placed at the center or not? Only radius has got changed. Did charge get changed, guys?
No.
No. So what will be, whether radius is 10 centimeters or 5 centimeters, charge enclosed in that sphere will be constant. So as charge enclosed is constant beta, what we can consider, we can say that flux is going to remain same. So if it was 4 into 10 cube, it will continue to be 4 into 10 cube. Understood? Understood why on changing the radius, charge inside the sphere is not changing. So charge enclosed is not changing means flux is not going to change. Understood, all of you?
Yes, yes, sir.
Uh, Very important question of calculating the electric field and potential, guys. Consider a rhombus A, B, C, and D as shown in the figure. A charge plus Q placed on the corner A produces electric field E and potential V at corner D. So this charge is producing field E and potential D. If we now place charges minus 2q and plus q at corners of B and C, now the magnitude of electric field and potential they are asking. Now please try to understand. In case of rhombus, are all sides equal? Beta? Yes or no?
Yes.
Yes. All sides will be equal. Suppose if only A charge, this charge is given. So what is electric field now at point D due to a charge? Will it be kq by x square or not? So I can write electric field E can be written as kq divided by x square. When in the absence of charges at B and C. And what we can write potential as, I can write it as kq divided by x. Okay. Now what they are asking, if I am taking these charges, what will be the situation? Now please consider the situation, guys. Here you have x, here you have x. This is 120 degrees, right? So our interest is to calculate what? Hmm, what they have given, consider rhombus ABCD as shown in the figure. A charge plus Q is placed at corner A, produces electric field E and potential V at corner D. So because of A, we got some potential and field at D. If we now placed minus 2Q and plus Q charge at corners B and C, now the magnitude of electric field and potential at D is how much they're asking. So what would be electric field, guys? You please see. First and foremost, student, very simple logic. Q will attract, sorry, if I take test a charge, Q will repel, guys. Yes or no? C will also repel or not? Yes. But what will happen to B? B will going to attract, guys. Understood, all of you? They're asking us to calculate what would be the resultant electric field. So I'll just keep them aside. I will take a new diagram for proper explanation, guys. We have a rhombus something in this manner we can take. Okay. We have a rhombus something like this. Right. So here we have charge Q. Here we have charge minus 2Q. Here we have charge Q. Now I want to find the effect due to these charges. So I'll take this as X, X, X and X. Okay. Now I want to find what would be at point D the electric field, guys. Okay. Now please tell me, at any point if you want to find field or potential energy or force, at that point are we going to place test charge? Yes. So if I place test charge, what will the Q charge do? It will repel. What will this Q charge also do? It will also repel. Now please tell me, will these two forces be equal or not? Yes, these two forces will be equal. And what is the angle between them, you see? If this is 120 degrees, automatically this will also be 120 degrees, guys. Because both are same in magnitude, I will get the resultant to be along 60 degrees again. You will get the resultant something like this. Clear, all of you? Yes or no?
Yes, Siddhu.
Right. Now what will be the resultant, guys? The resultant of these two forces only I want. Will resultant of these two forces be under root of f square plus 2 into f. Will I get cos 120 or not? Yes or no, guys? Cos 120 can be written as minus sine 30. So this will be f square plus f square will be 2f square plus 2f square. Cos 120 will be how much, beta? Cos 90 plus 30 you can write. Cos 90 plus theta will be minus sine theta. So I'll get it as minus 1 by 2. So what will I get? Under root of 2f square minus f square. Will I again get it as under root of f square, which will be equal to f, guys. So the resultant of these two forces will be equal to f. Okay. Now what will minus 2q charge do? Minus 2q charge, is it going to attract or not? Yes, it is going to attract. Okay. Now please tell me what will be so how much is this side? 120 degrees. So automatically what will this side be, beta? Can I take it as 60 degrees? Yes or no? Now by using cosine rule, I'll find this distance. Let us say this distance is r. Okay, what will the distance be? I'll write it as a square plus b square minus 2ab cos of angle between them, guys. So there is a certain formula again which is called as cosine rule. I can write c square as a square plus b square minus 2ab cos of angle between them. Let us say theta is the angle between them. Okay, so let us say this c is nothing but r over here. X is a and y is also, sorry, small a is x and b is also x, guys. So from this what we can write? A square plus a square minus 2ab cos 60 is again 1 by 2. So a square plus a square minus 2a square into 1 by 2, again you'll get a square. You'll get the value as again x only, guys. This will also be again x only. So what will I get the force here? I'm going to get this force as what we can write, because it is minus q charge, guys. So I'll get it as 2kq divided by x square. Okay. So two forces I have. One is kq by x square in this direction. Other is 2kq by x square in this direction. So what will our field be, beta? Our field will be, our force is something in this manner. Force by mass will force by charge will be anyhow field. So you'll get a field something like this, which is kq divided by r square. So because it is kq divided by x square, initially also we got E value as kq by x square only. So electric field will remain E itself, guys. Potential, if you want to find, due to this charge, it is kq by x. Due to this charge, it is kq by x. So overall, due to these two charges, we got 2 kq by x. And due to this charge, it will be k into minus 2q by x. So kq by x, kq by x minus 2 kq by x. So overall, you'll
Zero.
get potential as 0 only. So electric field will remain E itself. Potential will be 0, guys. Clear?
Yes, sir.
Right? Very direct question again, guys. But it's a good question again. We have to use something called as cosine rule. If you know two sides and the included angle, if you know two sides and the included angle, so automatically there's no need of using cosine rule. You know two sides already, and if one angle is 60 degrees, obviously the other two angles should be equal or not. This you can take 60 and 60 only. So there is no need of cosine rule, guys. You can directly use equilateral triangle also. Clear, all of you? Now, what they are saying, if a dielectric slab of dielectric constant K is introduced between the plates of an isolated charged capacitor. Again, capacitor is isolated. What is being done? Dielectric slab is being introduced. So what will happen to energy, guys? Achha, what will happen to capacitance? Capacitance will become K times charge constant. So what will happen to potential? Will also become K times potential difference. And what will happen to the, what do you say, energy stored, guys? Energy stored is written as half CV square or not? Or you can write half into Q into V also. Will it also become K times, guys? So initially, what is the energy? Let us say initially energy is U naught. Now, what will happen to the final energy? It becomes K times of U naught. K value usually will be greater than 1. So what is the change now? It will be K U naught minus U naught. So I can write U naught, if I take common, you'll get it as K minus 1. So it is increasing by K minus 1. Clear?
So, but we wrote it as
Hmm.
E naught by K as the energy stored when the battery is not connected.
When the battery is,
Not connected, we wrote it as E naught by K.
is that so? When battery is not connected, capacity C dash will become K times of C naught. Charge will remain constant, no? So Q dash will be equal to Q naught only. So what will happen to V dash? V is written as Q by C, no? So it will become V naught by K. Yeah. So energy will be half into Q into V. It will become U naught by K. This you can write U naught divided by K. So it will be decreasing, guys. So U naught by K minus U naught. So I can write U naught common. You'll get it as 1 by K minus 1. Okay. Or I'll write it as minus of U naught into 1 minus 1 by K. And what is this minus sign indicating? It indicates that the energy will be decreasing. Clear? So it decreases by U naught into 1 minus 1 by K. Clear, all of you? Yes or no? Isolated capacitor, dielectric is introduced. No change in charge, right? Capacitance will become K times. Potential difference gets reduced by K. Field, the energy stored also will get reduced by K times. Understood, all of you?
Yes.
Right. Let us see the next question. Capacitance of a parallel plate capacitor is 12 microfarad. If the distance between the plates is doubled and area is halved, what is the new capacitance, it seems? Parallel plate capacitor, what is capacitance given as? Epsilon naught A by D. Yes or no, beta? What are they saying? Area is halved. So C dash value will be epsilon naught A dash divided by D dash. Area is given as halved. I can take it as A by 2. And what is happening to the distance between them? Distance became doubled. So will it become 1 by 4 times of epsilon naught A by D, beta? So epsilon naught A by D is nothing but C by 4 here. C value is given as already 12. 12 by 4, you will get it as 3 microfarad. Understood? Did you understand, all of you?
Yes.
Capacitance for a parallel plate capacitor is epsilon naught A by D. If area is halved, the distance is doubled. What will happen? The capacitance will get reduced by 4. Okay. Now I have already told you this question. See, 4 particles, each having a charge Q and Q are placed at the 4 vertices only. Where are they placed? At 4 vertices. If they are placed at all 6 vertices, if they are placed at all 6 vertices, what would be the field at the center?
0.
0. But is it placed at all 4 vertices, guys? No, it is not placed at all 4 vertices. It is placed at only sorry, it is not placed at all 6 vertices. Just a second. So if it is placed at all 6 vertices, what I will say, electric field at center will be 0 because it is a regular polygon again. Now, what I'll do is at this vertex, I will add and subtract charge. Did I make any change? Did I make any change? At this vertex, again, I will add and subtract charge. Did I make any change?
No.
Arey yaar. No, I have not made any change, guys. So what we can do in this situation is very simple logic. We can take it something like this. I can take it as a combined effect of, देखो, cyclohexane you can take, where we have charges on all vertices. Yes or no? Plus, again I will take cyclohexane, but with charges only on how many vertices now? 2 vertices. See, देखो ये Q, 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 Q and Q. Definitely important question, guys. In second case, you have minus Q and minus Q. Okay. They're asking us to find what is electric field at the center. Please try to understand. In this case, what is electric field at center? For first case, electric field at center क्या है भाई?
0.
0. Second case, you see here in this case, what will negative charge do, beta? Negative charge will attract. This negative charge will also attract. Hexagon is made out of 6 equilateral triangles, guys. So what is the angle between them now? 60 degrees. So I have two forces here, guys, or two fields, you can say, something in this manner. And they are inclined to each other by how much angle, beta? 60 degrees. And both those fields are same again. So you can write here also E only, here also E only. So what will I get the resultant field if they are asking us to find the resultant field, guys? So what is our resultant field? Two fields are inclined to each other by 60 degrees. So I can write it as under root of E square plus E square plus 2 into E into what is angle between them? Cos 60. Cos 60 is how much again? 1 by 2 will I get or not, guys? So cos 60 और ये 2 चले गया. E square plus E square plus E square will be root over 3 E square, which I can write it as root 3 into E. And what is that E value? It will be KQ divided by, each side has, I think, side is given as A. So root 3 KQ divided by A square should be the net field at the center, guys. Clear, all of you? Yes or no, everyone? So whatever hexagon was there, I made a small construction in it. On the two vertices, I have added charge Q and subtracted charge. Added charge Q and subtracted charge. Did I make any change? No. So I will just take this as two combinations. One will be a cyclohexane with all positive charges. Other will be a cyclohexane with two negative charges. So what will these negative charges do? They are going to attract the test charge, guys. So that is the reason we are going to get two fields inclined to each other by 60 degrees. So the net field will be root 3 times of the general field, guys. Clear? Yes or no?
Yes, sir.
Minimum possible electrostatic force of the minimum possible electrostatic force of attraction between two point objects placed at a separation of 1 centimeter, they are asking. So what is basically electrostatic force given as? K Q1 Q2 divided by R square. Minimum they are saying, minimum means Q1 and Q2 value will be equal to E, guys. So K value, if I consider, it is 9 into 10 power 9. Q1 and Q2 both should be equal and they should be equal to basic unit of charge, E value. E is 1.6 into 10 power minus 19. So if I write E into it, it will become E square. Yes or no? So I'll write 1.6 whole square. What will I get, beta? 2.56 into, so basic unit of charge 10 power minus 19. Now if I do whole square, I'll get it as 10 power minus 38. divided by r square. Separation is already given as 1 centimeter, so I can write it as 10 power minus 2 whole square. Clear all of you? अब ये देखो 38 is there, 9 is there, so you'll get minus 29. Minus 29, and in denominator you have minus 4. I'll get minus 25. Yes or no, all of you? So what will this be? 9 to the 18, you all know, right? So somewhere around 22 you'll get, guys. So 2.3 into 10 power, how much will I get? Minus 25 will you get or not? 25, 24.
24.
ठीक है. You're going to get it as 25 you are getting, no? 20 point you will get, sorry. 23 you will get because 9 to the 18, no, yaar. 9 2.5 will be 23 into 10 power minus 5, which I can write it as minus 25, sorry. Which I can write it as 2.3 into 10 power minus 24. Is that clear? Is that clear, everyone?
Yes, sir.
Right. So 2.3 into 10 power minus 24 Newton will be the minimum possible electrostatic force between 2 point objects. So for the force to be minimum, they should have basic unit of charge, which is E, guys. 1.6 into 10 power minus 19 coulomb. Clear, all of you? Force on a charge due to another charge. Again, the statement was given yesterday, guys. Whenever we are trying to find force on one charge due to the other, will that expression include other charge, guys? Will it include third charge?
No.
No, it is not going to include the third charge. Direct statement. Depends on the presence of other charges? No. Is independent of the presence of the other charges? Yes. Depends on the presence of other charges and their sign? Not at all. Depends on presence of other charges, their signs and distances? Also not, guys. So it is independent of the presence of the other charges. It is a very, very good question again. So whenever we write the equation for Gauss law between, for Newton's law, Coulomb's law, sorry, not Newton's law. If we write the equation between Coulomb's law for two charges, right, that particular expression will be independent of the third charge present in the system. Clear, all of you? Yes or no?
Yes, sir.
And we have next case, which is two equal positive charges are kept at points A and B. The electric potential at point A and B is studied while moving from A to B. What is the potential they are asking? Two equal charges have been placed. You can consider at points A and B, guys. The electric potentials at the points A and B, excluding these points, is studied while moving from A to B. So I'm not talking about point A or point B. Excluding this, I'm talking. So what will happen to potential they're asking, guys? Now please tell me. If I take, again, I'll just take the some larger diagram, guys, just for understanding purpose, because it's a good question again. So two charges I have taken, kept at some separation. Yes or no? Now what they are saying, as you move from A to B, what will happen to the potential value? Okay, so first and foremost, what I'll do is, I'll take midpoint beta. Right, so midpoint means because of A, you will get KQ by A. Because of this also, you'll get KQ by A. Right, so you'll get it as 2KQ by A here. Now, you please try to understand just close to A. I'll take 1 point close to A. So close to A means what will be distance between the given point and A? Almost zero. So here you are going to have a large value of potential, guys. As you move, so here you got a finite value of potential. Again, as you come to this particular point, what will happen? Again, the charge is at almost zero distance, so you will get infinity again. So first you have infinity, then it will decrease, right? And again it is going to increase. So first what will happen? Decreases, then it will be increases as it is moved from where to where? From A to B. Clear, all of you? What is potential at this point? If I say this point P, what we can write it as? If I take this as A and A, guys, so I'll get it as KQ divided by A due to first charge, and due to second charge also KQ by A. You will get it as 2KQ divided by A. Okay, whereas if I take this particular point, because it is very close to the charge, separation will be 0. Anything divided by 0 will be infinity. Here also, because it is very close to the charge, separation between them 0. Anything divided by 0 would be infinity. So first infinity, then reduces to 2kq by a, then again moves to infinity. Clear? So it will first increase. Sorry, it is first going to, sorry, what did I type here? So it will first decrease, again it will increase. Clear all of you? Here what is the value? Here potential value is infinity. Here also what is potential value? Infinity. And what is potential at point P beta? You got it as 2kq, 2k small q divided by a. So as you can see, it is from becoming infinity to 2kq by a. Again from 2kq by a, it is becoming infinity. First decreases, then increases, guys. Clear or no? Next question, let us see. Two small two insulating small spheres are rubbed against each other and placed 3 centimeters apart. If they attract each other with the force 0.256, then the number of electrons transferred from one charge to the other, they are saying. Right. Two insulating small spheres are rubbed against each other and placed 3 centimeters apart. If they attract each other with the force 0.256 Newton, then the number of electrons transferred from one sphere to the other. So initially, you can consider, again, charging by friction I have explained. One will become positive, other will become negative. So how will I write the electric force as beta? I can take it as, we know it is k q1 q2 divided by r square. So two insulating small spheres are rubbed against each other. They are kept 3 centimeters. Now, what is the force given? 0.256. K value 9 into 10 power 9. I want to find charges. Let us say they have same charges, guys. Will I get q square divided by, right? What is r value? 3 centimeters is given. So I can write 9 into 10 power minus 9. Sorry, 9 into 10 power 3 centimeters, no, minus 4 you will get. R square we should do, no, yaar. So centimeter square means minus 4 you will get. Okay, so what we can do here from this, 9 and 9 gaya. So bacha kya? 0.256. 0.256 into 10 power minus 4. So you will get it as, if I send this in numerator, 0.256 will be equal to, I think, 10 power 13 into q square. So what will q square value be beta? It will be 0.256 into 10 power minus 13. So I can write q square value as 2.56 into 10 by 10. If I do, guys, you will get it as 10 power minus 14. So what will q value be? If you do square root, I think I'll get it as 1.6 into 10 power minus 14 coulomb. Okay. So how many electrons got transferred, they are saying, guys. Again, charge can be quantized, we have written. So can I write charge in terms of basic unit of charge or not, guys? So I can write n into E will be 1.6 into 10 power minus 14. So n into 1.6 into 10 power minus 19, will it be equal to 1.6 into 10 power minus 14? Guess or no? Charge is equal to n times of E. So from here, what we can cancel out? 1.6, 1.6. So what will n value be beta? We get it as 10 power 5.
So it is minus 7.
Where?
So after taking the square root, q.
0.256. I wrote 2.56 into 10 by 10 you will do, no? So this will become minus 12, I guess. Am I right?
So I mean,
No,
so
minus 14 only. Acha,
after
square.
taking,
Acha, okay, okay. This will become minus 7, guys. This is also minus 7. This will be minus 7. So how much will be left out? 10 power 12 will be left out, I guess. So 1 into 10 power 12 should be the answer. Direct based on quantization of charge, guys. Understood all of you? Q will be equal to N into E. Any doubts in this, everyone?
No, sir.
Next, I think we did this question. Let us try to do this question, guys. A capacitor of capacitance 1 microfarad withstands a maximum voltage of 6 kilovolt, while a capacitor of 3 microfarad withstands a maximum voltage of 4 kilovolt. The maximum voltage which the capacitors can withstand when connected in series, they are asking. Okay. You please see, capacitor of capacitance 1 microfarad can withstand how much beta? Maximum voltage of how much? 6 kilovolt or not, right? And so 6 kilovolt means what will be charge stored in this? Charge can be written as C into V, no? So I'll get 6 into 10 cube into 1 into 10 power minus 6. So I'll get it as 6 millicoulomb or not. In the same manner, second capacitor you take, it can withstand how much, guys? 4 kilovolt. So what would be the charge in second capacitor? It is given as 3 microfarad. So you have 4 kilovolt, guys. 4 into 10 cube into 3 into 10 power minus 6, guys. So what I'll get? 12 into 10 power minus 3. Will I get 12 millicoulomb or not? So what is the total charge that they can bear if they are in series? Yes, conservation of charge is again applicable, guys. You will get it as 18 millicoulomb. Now in series, guys, what is the maximum voltage? Maximum charge they can store is 18 millicoulomb. Okay. So a capacitor of capacitance 1 microfarad withstands a maximum voltage of 6 kilovolt with a so maximum charge that Q1 can store will be 6 kilovolt. And sorry, maximum charge that Q1 can store is 6 millicoulomb. And C2 that can store will be how much beta? 12 millicoulomb. So when they are connected in series, should charge be same or not? Yes, when they are connected in series, charge flowing should be same. So if I take charge as 12 millicoulomb, right? Will C1 be able to store that charge? No. So we cannot take 12 millicoulomb. So I will consider that 6 millicoulomb will be stored, guys. Now what is C effective if both are connected in series? You know, it will be given as C1 C2 divided by C1 plus C2. So 1 into 3, 3 divided by 4 you are going to get. So we got C effective value, which is microfarad, and we got the total charge. They're asking maximum voltage that they can withstand. So can I write it as V value can be written as Q divided by C effective. So they can withstand 6 millicoulomb, 6 into 10 power minus 3. C effective we got 3 by 4. So we'll get it as 8 into 10 power minus 6 will be the microfarad is there, no? So 8 into 10 cube you will get, which will be 8 kilovolt, guys. You understood question? In series combination, both should carry same charge. Yes or no? Both should store same charge. Maximum charge that can be stored by first capacitor is 6 millicoulomb. Maximum charge that can be stored on second capacitor is 12 millicoulomb. Can first capacitor store 12 millicoulomb? No. So maximum first capacitor is storing 6 millicoulomb means maximum that much only will be stored in Q2 also. And if they are connected in series, can we find effective capacitance? Yes, you already know the charge. So can we find the potential difference, guys? Yes, we can find the potential difference. Clear all of you? Yes or no, yaar? Next question, let us see. Probably the last question for the day, guys. Rest of them will clear tomorrow. Three charges are arranged on the vertices of an equilateral triangle. The dipole moment of the combination. Very important question, guys. Dipole is what? Set of two equal charges which are same in magnitude and opposite in direction. So what I'll do to this minus 3q charge is, can I write it as minus 2q and minus q? Yes or no? And whenever we are talking about dipoles, always directed from negative charge to positive charge, you are going to have one dipole moment. So are dipoles formed or not? Yes, dipoles are formed. You see, minus q and q will form first dipole. Minus q and minus 2q and 2q will be formed second dipole, guys. So what will be dipole moment for first dipole? If you can just tell. P1 value, I'll just use different color. P1 value, if I'm writing, guys, what will it be? Charge times of separation, which is A. In which direction? I cap. And P2 bar if I take, what are we going to get? Again, if I not write the directions, guys, let us just take the magnitudes again and finally we can. So I have two dipole moments here. One is like this, P1 bar, and other is like this, P2 bar. So what is the angle between them? You all know it is equilateral triangle, so you'll get it as 60 degrees. So what is P1 here? P1 value will be charge times of separation A. What is P2? Again, it will be 2Q times of A, which is again given as 2QA. Okay. Now these two dipole moments are separated by an angle 60 degrees. So what is the net dipole moment beta? You can write it as directly under root of P1 square plus P2 square plus 2 P1 P2. Cos of angle between them is how much? 60. Cos 60 and 2. Will it get cancelled out? Yes, it will get cancelled out. So what are we going to get? P1 value as under root of QA whole square plus 2QA whole square plus QA into 2QA. So Q square A square, 4Q square A square, 2 again. 4, 6, 7 you will get, guys. Under root of 7Q square A square you are going to it, which will be root
So it's
7
nine.
times of 9, is it? 2 and 4. అరే 2, 4, 6, 7 కదరా తమ్ముడు
Yes, sir.
ఏమ్రా భయ్ 7Q square A square you will get, which will be root 7 times of Q into A, guys. This will be our resultant dipole moment. So again, definitely such type of questions will also be asked. Okay.
Sir, 2 into
Huh.
QA into 2QA.
అరే కాస్ 60 రెండు పోయినాయి కదరా కాస్ 60 ఇంకా 2 క్యాన్సిల్ అయింది కదా
Okay.
root 7 QA will be the answer for that. Understood, all of you? So let me just check how many more questions are there. So basically we have covered today what is maximum torque experienced by dipole. We have seen potential questions. We have seen capacitance questions. We have calculated dipole moment. We have also seen flux questions, guys, how to calculate flux, right? So different model questions we have discussed. Right, so good amount of questions only we have discussed, guys, today. Rest of the questions we will be discussing tomorrow. Whatever are possible, we will complete, we'll discuss tomorrow and we'll move on to current electricity, guys. Clear, all of you? Is that clear, everyone?
Yes, sir.
Chalo, Harshit, I'll explain tomorrow, yaar, okay?
Okay, sir.
Right. Chalo, guys, take care. Thank you all. I will add you people now. I will add. Yesterday, I think I got few email IDs, guys. So I will add all those email IDs now. You will get access to OneDrive. Okay, in that you are going to have the recordings of the classes. You can listen anytime instead of you sending me a request and all. Okay.
So would there be test also?
Test also I'll keep in that only in that folder. I'll share that folder with you people. Okay.
Okay, sir.
Right.